Hello everyone, in this video we are going to discuss the example for differentiation. Find the dy dx for the situation. Here we have x cubed multiplied with the cos 3x. So making use of the product rule, v u prime plus u v prime. So here we have the u and here we have the v. So we have the dy dx where we have the v, cos 3x. Differentiate the u. So we will have 3x squared. Plus we have the x cubed. Differentiate the v, so we will have bracket negative sine 3x. Differentiate the internal function, then we will have 3. So rewrite the situation, dy dx, where we have 3x squared cos 3x minus 3x cubed sine 3x. So that is the dy dx for this case. Continue. Find the gradient for xy plus with the y multiplied with exponent x plus with the x exponent x at x equals to 0. So before we start the differentiation, kindly find the value of y. So if we substitute x is equals to 0. So here we will have 0 multiplied with the y plus y multiplied with the exponent 0 equals to 0 multiplied with the exponent 0. So here we will have 0. Here we will have y equals to, here we have 0, here we have the 1. So the answer of y will be 0. So here we have x is equals to 0, y is equals to 0. Next, focus on the differentiation. We have the xy plus y exponent x equals to x multiplied the exponent x. Find the gradient, meaning that find the dy dx. So making use of the product rule, we have v u prime plus u v prime. So let's say here we have the u and v. So let's begin. We have the y multiplied with the 1 plus we have the x. Then we have the dy dx. Continue. Here we have the u and here we have the v. Plus we have the exponent x. Differentiate the u where we have y prime. Plus we have y. Differentiate the v prime. Then we will have the situation exponent x equals to, focus on this part, we have u and v. So differentiate the situation, exponent x, differentiate x, we'll have 1. Plus we have the x, differentiate the exponent x, then we have exponent x. Kindly rewrite the situation. So focus on this part. We have the y prime, bracket, we have the x plus with the exponent x, equals to, we have the exponent x plus with the x multiplied with the exponent x, and then minus the y, and then minus the y exponent x. So the dy dx, where we have exponent x plus with the x exponent x minus the y exponent x over, we have the x plus with the exponent x. When x is equals to 0, y is equals to 0. So the dy dx will be equals to, here we have 1 plus with the 0 minus the 0 minus the 0 over, we have the 0 plus with the 1. So the dy dx will be equals to 1. Given the parametric equation, so here we have the y which is equals to t squared over t plus 1 and the x where we have 1 over t plus with the x. Evaluate the second derivative at the point 1 over 2, 1 over 2. So kindly find out the value of t by substituting the value of x 1 over 2, the value of y 1 over 2. So here we have y which is equals to t squared over t plus with the 1. If we substitute 1 over 2, then we will have 1 over 2 which is equals to t squared over t plus with the 1. Cross multiplying the situation, we have t plus with the 1 equals to 2t squared. 2t squared minus the t minus the 1 equals to 0. Factorize the situation. We have 2t plus with the 1, t minus the 1. So from here, t is equals to negative 1 over 2, t equals to 1. Next, kindly substitute the value of x. Here we have x is equals to 1 over t plus with the 1. Substitute 1 over 2, then we have 1 over t plus e to 1. So t plus equal to 1 equals to 2. So t is equals to 1. So as for the conclusion, when x is equals to 1 over 2 and y is equals to 1 over 2, the value for t would be t equals to 1. So that is the conclusion. So let's begin. Here we have y is equals to t squared over t plus equal to 1. Then here we have x is equals to 1 over t plus equal to 1. So kindly differentiate the situation. We have the dy dt, where we have t plus equal to 1. Then we have the 2t minus, we have the t squared bracket, we have the 1 over t plus equal to 1 bracket square. So we have 2t squared plus equal to 2t minus the t squared over t plus equal to 1 bracket square. So the dy dt will be equals to t squared plus with the 2t over t plus equal to 1 bracket square. So that is the dy dt. Continue. dx dt, where we have negative 1 over t plus equal to 1 bracket square. Next, find the dy dx, where we have dy dt multiply with dt dx. So kindly substitute. We have the t squared plus with the 2t over t plus equal to 1 bracket square. Multiply. Kindly flip the situation. We have the negative t plus equal to 1 bracket square over the 1. So we have the dy dx, where we have the situation t squared plus with the 2t bracket, we have the negative. So as a conclusion, the dy dx, which is equals to negative t squared minus the 2t. So find the second derivative. In order to find the second derivative, we have the formula. Differentiate the dy dx with respect to t. Multiply with the dt dx. So let's begin. Differentiate the dy dx, which means that this part. We have the situation negative 2t, negative 2. Multiply with the dt dx. So here we have the negative bracket t plus equal to 1 bracket. We have the square. So kindly rewrite the situation, factor out the negative 2, then we have t plus equal to 1, multiply with the negative, then we have t plus equal to 1 bracket square. So rewrite the situation. For the second derivative, we have the situation 2 bracket t plus equal to 1 bracket cube. Kindly substitute the value when t is equals to 1. So the second derivative will be equals to, we have 2 multiply with the 2 to the power of 3. So we have 8 multiply with the 2. So the second derivative will be equals to 16.
If you are new here, kindly consider subscribing to this channel and share this video to your friend. Thank you so much for watching this video. Bye.